Okay guys, so I would like to walk you through all the different problems that we have in our book, and let's start with chapter 1. So this is our chapter 1 and it includes elements, atoms, and periodic table. To solve the problem on page 88, it would be the best if you have a periodic table with you. You can look up for the answers in your periodic table. So first question is, which of the following substances are elements? Since periodic table contains only elements, then it would be easy to look for the answers. In this particular question, the correct answer would be sodium, gold, and liquefied nitrogen. So like I wrote, don't let the word liquefied confuse you because nitrogen is still an element and it's just in a different state. Nitrogen is known to be in not liquefied and not as a solid, but mostly as a gas. So liquefied nitrogen is still an element. So, which of the following substances are element? Like I said before, it is very easy when you have a periodic table next to you. So you can look it up. Paper is obviously not an element. Electricity is not an element. Neon and carbon are two elements in this problem. Wood is not an element. Concrete is not an element. This type of question you can definitely do by just using the periodic table and making sure that you can find every single element that is provided to you in a periodic table. It might be difficult in the beginning, but as you walk through the whole periodic table, you will see that it's very easy to find certain elements. For example, like silver or sulfur, nitrogen, or neon. Here is in red. I provided all their symbols. Question 4 is very similar to the one that we just did. Make sure that you know that the first letter of the chemical symbol for each element is capital and the rest are the lowercase. So bromine is usually represented as Br, oxygen is O, lithium is Li, and boron is just letter B. Question 5 is asking you to explain why it is improper to write CO, two letters are capital, as the chemical symbol for cobalt. It is incorrect to write it that way because cobalt as an element has a symbol C as a capital letter and O lowercase. We know that elements consist of only one capital letter and the rest are lowercase. Because if you look at CO, this is a completely different substance and it's called carbon monoxide. Carbon monoxide consists of two different elements. It's carbon and oxygen. Absolutely the same problem with nitrous oxide. NO. So it consists of nitrogen and oxygen. Therefore, it has two different elements and it's not one element. Okay, a different question that we'll be asking you about on page 109, because now we're starting to look at the composition of each element. So each element is composed of protons in the nucleus and neutrons. Outside of nuclei, you have electrons that are constantly moving. By knowing the number of protons, you can identify what element it is, because you will know the atomic number of your element. All atomic numbers are represented in periodic table. By knowing the atomic number, you know the number of protons. Protons identify elements. So, number of protons are equal to the atomic number. So what is the question on page 109? How many protons are in the nucleus of each element? And as an example, A, you have an element, radon, and it has 86 atomic number. Therefore, the answer is 86. You need to memorize that the atomic number is equal to the number of protons. Therefore, you can look it up very easily. If you have a periodic table next to you, you can find out that atomic number for chromium is 24, therefore it has 24 protons. For beryllium it's 4 and has 4 protons. So question 2 is asking how many protons are in the nucleus of each element, and they provide you a list of different elements. So let's look at sulfur, and this is just a small screenshot from my periodic table. You're looking for sulfur. This is the atomic mass, and 16 is your atomic number. Atomic number represents the number of your protons. Therefore, sulfur has 16. If you look in the periodic table, you'll see that uranium has an atomic number of 92, therefore 92 protons. Calcium is 20, and lithium is 3. Okay, so what question 3 is asking you, what are the atomic numbers of the elements in exercise 1? This is pretty much the same answer, and we just talked about it. Same answer as the number of protons, and same number as you would be looking in the periodic table. So, just look it up again. Question 1, where is it? 86, 74, 24, and 4. Absolutely is the same answer for exercise 2. How many electrons are in neutral atoms of the elements in exercise 2? Okay, how many electrons are in neutral atoms of the elements in exercise 2? This is very important because it's asking you neutral atoms. It doesn't have a charge. Neutral atoms means that it has the same amount of electrons as the atomic number, therefore as the number of protons. So by knowing the atomic number, you can find the number of protons and you can find the number of electrons. Make sure that you know that this is a neutral atom, not positively charged, not negatively charged, neutral atom. So the atomic number of sulfur is 16. Therefore, in the neutral atom of sulfur, there are 16 electrons. Okay, this is a fun thing. Complete the following table. It is a good practice for you, and it looks like one of those questions that might be on the test. So how do you start? In red is the answer already, right? And this is kind of easy. But in black is the numbers that were given to you. So you have a number of protons, therefore you can find out what element it is, and the number of neutrons. By knowing number of protons and neutrons, you can find the atomic mass. You cannot use the number of atomic mass that is given to you in periodic table for this specific element, for this specific example, because sometimes mass can be more than what is given to you or less from what is given to you in periodic table. So you know the number of protons and you look it up in your periodic table and you find out that this is Mercury. And then you add up these two numbers to find out that the mass of Mercury is 280 plus 120 is going to be 200. And I explained to you over here what is the element name, and this is Mercury. you have to look at the number of protons, and since it equals the atomic number, and for mass, you'll add up the protons and neutrons. So over here, you have three points that you know. So first of all, this is iron. You know the atomic number, and you know the mass. So by knowing the atomic number, you can write that it is 26, right? The number of protons. And to find out the number of neutrons, you have to minus 26 from, which is the number of protons, from the atomic number. And now you know the number of neutrons is 29. And over here, it's just asking you the name of the element, which is iron. Over here, you were given only two numbers, which is 2, the number of neutrons, and the name is hydrogen. So if you know that this is hydrogen, you can look it up in the periodic table, and this is your first element, which is H, right? H, and you know that it has 2 neutrons. You know the atomic number of hydrogen, which is 1. This is given to you. Remember, mass can be different. So you write 1 only has 1 proton. How do you find the final mass? You add your protons and neutrons. And this is your final mass. It has atomic mass of 3, which is weird because in your periodic table, it should be 1. But this is one of those examples when I told you that you cannot just copy the mass that you were given in a periodic table. You have to find out if you were not given it. This is the same type of a table that you can complete by looking at the numbers, and I have given you the examples already, right? I have given you the answers already. I would like you to finish this problem by yourself and see if you can actually figure it out, the answers, without me, without my answers, you know? Okay, next one. State the number of protons, neutrons, and electrons in neutral atom of each isotope. So, you are given an isotope. This is a symbol of an element and the mass, right? So on top, you have your mass. On the bottom, you have atomic number. So here is our mass, is 131. So by looking up in the periodic table for iodine, you can find that it has 53 electrons. By the way, this is a symbol for electron. 53 protons, because the atomic number is 53. And how do you find neutrons? You have your mass, and you minus your protons. 131 minus 53 is 78 neutrons. You do the same thing for potassium. Potassium has 19 electrons, 19 protons, because the atomic number is 19 for potassium. How do you find your neutrons? 40, the mass, minus 19 is 21. Same thing for mercury. Mercury, this is a symbol for mercury, has a mass of 201. You have to find what's the atomic number for it. You know the atomic number is 80, therefore it has 80 protons, 80 electrons, and to find neutrons, you have to minus 201. You have to minus from 201, 80, and you'll find out that it has 121 neutron. Okay, so the only one that's actually needing you to do some work are the neutrons. They're kind of tricky, but that's okay. For fluorine is the same. Fluorine has an atomic number of 9, therefore it has 9 electrons, 9 protons, and to calculate your neutrons, you have to minus 9 from the mass of 19, and therefore you'll find out that it has 10 neutrons.